Okay, welcome Year 10s to this first video in the bivariate data topic. What we're going to be doing is looking at how we analyze two numerical variables. So that means two variables that are using either counted or measured data. So obviously the data that you're looking at is going to have numbers within it. When we have two variables and we're trying to analyze them, we're really looking for whether there's a relationship between them. Now, this word relationship, we don't always use that to refer to what I'm talking about. We sometimes use this word correlation or association. So we're trying to have a look and see, is there a pattern that emerges when you look at the data of those two variables that you're looking at? So when I talk about a relationship, what I mean is if we have a look at these examples here. If you look at the height of a person and the weight of a person, so if you just take a random scattering of people, say you just were to interview them on the street, and you were to take their height and you were to take their weight, would you see that there would be a pattern emerging? So basically, yes, if you've got, say, a 30-year-old and you record their weight, and then you come across, say, a 2-year-old and you record their height and their weight, you're going to see that there's going to be a big difference. There's going to be a larger height equating to a larger weight, and that's really because a lot of that is associated with age. There can be obviously other reasons why height and weight would be associated. So, for example, I'm not very tall, so if I've just got like if we just talk about a standard build, compared to another person who is much taller than me of a similar build, they are going to be heavier than me. So height and weight of a person, we do expect there to be an association or a relationship. Temperature and life of milk. So in other words, whether your milk is good or bad. Yeah, we could say yes, and that's why we keep our milk in the fridge, because obviously if your milk is going to be getting to a higher temperature, then the life of that milk is not going to be as long. Length of hair and IQ. No, definitely not. Otherwise, we'd all be growing our hair, no doubt, to increase our IQ, or the other way around if it happens to be that shorter hair leads to IQ being higher. So no, there is no association. We don't see any relationship between that data. Depth of topsoil and brand of motorcycle, again, don't really see how those two things could be related. This one though, years of education and income. So we do actually see an association between these. It means that if you are spending, I guess, many years in study, whether it be in higher education, whatever it might be, and the amount of money that you can earn, we do see a correlation between those two things. Spring rainfall and crop yield. Again, if you get some pretty good rainfall, that can have a really good effect on the crops that you are growing. Size of a ship and cargo capacity. So it basically means how big the ship is and how much it can carry. Well, yeah, we would expect there to be an association there. Small ships can't carry as much. Large ships can carry a lot more. Fuel economy and CD track. So no, when you're driving, you don't tend to use more fuel if you're playing a certain track in your CD player. Amount of traffic and travel time is a big one. Yes, definitely. The more traffic that you see on the roads, likely the more travel time you're going to have on the roads. Cost of 2 litres of milk and ability to swim. Again, can't see any reason why they would be related. And the last one, background noise and amount of work completed. Well, for some people, maybe some noise would be good for them, but for most people, in a noisy environment, you're not going to get as much work completed, so there would be an association there. So as you can see, all I've done there is just looked at the two, thought, is there sort of a logical explanation that that would lead me to think that there's something that's going to link those two things together. Now, after we've established that, a statistician might want to investigate. So they might take some data. And after they've taken that data, what they're going to do is they're going to display the data. So this is a display of numerical data, or two numerical data values, really. When there's two involved, we use scatter plots, which are basically a number plane. So think of like an X and Y axis. And we use each of the data values. So there'll be two pieces of information, an X and a Y. We don't use X and Y though. We tend to use this language of EV and RV. So I'll get to that in a second. So really a scatter plot is your visual display. And one of the good things about a scatter plot is it is going to tell you whether there is a relationship or not. So this question that we're asking up here, if you actually have the data and put it onto a scatter plot, you'll be able to decide whether you think there is a relationship. Okay, so when you are drawing a scatter plot, really important that the correct variable is assigned. So I'm just going to underline that. You can highlight it if you like, to each of the axes. So the reason we do that, the reason you need to decide is because we always put the explanatory variable, the EV, on the x-axis. And this response variable will always go on the y-axis. So I'll get to that in a second, but I'll just draw a little picture. We go EV, and over here we do RV. Now these used to be called the independent and the dependent variables. So if you're looking at other resources, you come across other resources that mention them, they are talking about the same thing. So you might like to consider these statements when you decide which is which. So generally we say that the EV may have an effect on the RV, or influences. The RV. So that's just a presumption. We don't know for sure. That's why I said may have an effect. We don't know that it influences it, but that's what we are investigating. We're investigating if it's having an influence. Or the RV is, or maybe, change that, maybe affected, influenced by the EV. Another way to put it, or because it used to be called the dependent, RV depends on the EV. So I'll use a couple of examples to highlight what I mean. So with this one here, we're asking, does the height depend on the weight, or the weight, does that depend on how tall you are? So we tend to say, or if I use this statement here, the EV may have an effect on the RV. So what we're saying is, does the height have an effect on the weight, or does the weight have an effect on the height? So in this case, what we're saying is your weight will really depend on how tall you are. So if we're considering, well, it depends on many things, of course, but one of the main factors in someone's weight will be how tall they are. Think about like a 30-year-old versus a 3-year-old. If you take age out of it, the main difference between those two people is their height, and that's why one will be so much heavier than the other. Temperature and life of milk, so this will be similar. We're saying that really this life of the milk, it really depends on what temperature it is. So the RV depends on the EV. Same with this one, years of education to income. Well, your income depends on how educated you are. Now that doesn't work for everybody, remember, but this is just generally. The crop yield depends on the rainfall. The cargo capacity, that depends on the size of the ship. The travel time to work, well, that depends on what traffic you had. And how much work you do, that really depends on the environment that you've been working in, so the background noise. So if you can find something that depends on the other one, you've found your RV, which is what I did in this case. Once you've established your EV and your RV, so which is which, sometimes you're even told that, so don't stress too much. When some of them are a little bit challenging, you tend to be told. We then want to draw a scatter plot. So the most important thing with a scatter plot is to choose an appropriate scale. So if you're looking at your data and you can see what the maximum value is on that data, it's a good starting point. Make sure that your axes extend to that maximum value. Make sure you use a ruler. Always use a ruler and try and space out the scale nicely. Label everything as well. The variable, so the data that you've got, that has to be labeled on each axis. And then each of your data points is one single dot on your graph. So it represents an ordered pair. So I'll show you briefly how you would do it, and then I'll show you the finished product for these two scatter plots here. The first one, we've got period of exercise and then blood cholesterol levels. So one thing that you may not be aware of is your blood cholesterol level. If you have high cholesterol, what your doctor will tell you to do is get some more exercise straight away. So that tells us that your blood cholesterol level can depend on how much exercise that you do. So here we've got exercise in hours and the blood cholesterol of that person. So what's important is that this represents one person. So you can't move this data around or change the order because this is a dot. Remember I said EV is your X, it goes on the X-axis, the horizontal, and RV goes on the Y. That means that this here is the ordered pair 6, 4 that we're going to plot. And this is the ordered pair 8, 3 that we're going to plot. So just zoom out a little bit. Just give you an idea of what to do before I show you the finished product. And you can do this yourself. We'll have a vertical axis and we have a horizontal axis. We will put the EV along the bottom. So this is period of exercise. And make sure you put the unit as well, hours. Now you'll see that the lowest is 0. So 0 is going to be right down the bottom here. And the highest for period of exercise is 16. So you need to make sure that this goes up to 16. So I'll just go halfway, I'll put 8. Oops, it should go underneath, 8. And 16. And then halfway would be 4. Halfway between them would be 12. And then I've got 2, 6, 10, 14. So you can space it out nicely and label it. I've put my label a little bit too close, as you can see. The next thing is over here, the blood cholesterol. So, oops. Blood cholesterol. And from here we've got well, we don't have minimum of 0, but we may as well, we've got low numbers here, the lowest being 3. So we can leave this 0 here, start from 0, and go up to 9. So if you've got space, you could just go up to 10 instead. So let's go 10, and then halfway would be 5, and then 1, 2, 3, 4, 6, 7, 8, 9. So you can label that appropriately, like I've done. Once you've got all that, you'll then plot 6, 4, so period of exercise 6, and then you'll go up to 4 and you put a dot. It doesn't need to be labelled, it just needs to be in its correct position. The next one would be 8 and 3. And then you'll go through each of those, so next one 12, 3, and then 16, 3, and you would plot all of those dots together. When it's finished, it should look like this one right here. If I zoom in a bit. So you can finish yours off and compare to this one here. With the next one, I won't plot it by hand myself, but I'll just talk about it here. You'll notice we've got temperature and number of pies sold. So we're saying that how many pies you sell really depends on what the temperature is. So this is your RV here. Now you notice that with the pies sold, the numbers are really big. So you don't want to start your axis at 0, because then you're going to have this huge space in your scatter plot that's blank. So what you can do, have a look here. Daily temperature maximum is 22. So if we space out nicely just by 5s, you can see here we go up to 30 degrees. So that will fit obviously the 22. And if you have a look at the number of pies sold, we can just put a little double line like this. It represents a break in the axis. So it means we're not starting at 0. We're actually going to start up here at 200 since our lowest value here is the 295. So if we go from 200, our maximum is just below 7. It means that we'll be able to fit everything nicely into that scale. And so there's the second one there. So notice we've got it labeled, number of pies and daily temperature in degrees Celsius before you start plotting. Okay, I'm going to stop there. So what you want to do is make sure that you complete the questions in the work plan that are to do with associations, so the EV and RV, and the creation of scatter plots.